Hey everyone, welcome back to my YouTube channel. I am Ranjitha. I am currently pursuing third semester BE in Sri Venkateswara College of Engineering, Department of Computer Science. Today we are going to discuss about mini project based on simple calculator with process scheduling and stack based operations with my team members Varshini L and Ranjitha.G. Let's go. Introduction. Project Overview. A program integrating calculator functionally, process scheduling and stack operations. Showcases practical applications of DSA, OS principles and basic hardware functionality. Objective. Demonstrate the interplay of software and hardware functionalities using fundamental computer science principles. Key components. Based on data structure and application, we are using stack operations like push, pop, and display conditions. Based on operating system, we are using first come, first serve process scheduling algorithm. Based on digital design calculator stimulating ALU functionality, we are using. And computer organization, we are using memory stimulation using stacks and task handling. Calculator functionality. A simple calculator is a device that performs basic arithmetic operations. We will explore the underlying mechanisms and functions of these everyday tools. A calculator is a program that performs arithmetic operations. Basic arithmetic operations. Addition. Adding numbers together. Subtraction. Taking away one number from another. Multiplication. Multiplying numbers together. Division. Dividing one number by another. Stack. A stack is a linear data structure that follows the last in first out LIFO principle. The primary operations of stack are push, pop, and pick. Push adds an element to the top of the stack, increasing its size. Pop removes the top element, reducing the stack size, while pick allows viewing the top element without removing it. Stack overflow occurs when there are attempts to push an element onto a full stack. Stack underflow happens when a pop operation is attempted on an empty stack. Advantages: simplifies resource management due to its sequential nature. Disadvantages: fixed size in static implementations which may lead to overflow. Next, continued by Vachini.
Hello everyone, this is Varshini L. In this project, the code include process scheduling concept. Let us discuss what is process scheduling. Process scheduling is a key function of operating system that manages the execution of process. FCFS, first come first serve, is the simplest scheduling algorithm where the process are executed in order they arrive, and the advantages of this is simple to implement and fair for processing arriving the first, and disadvantages is can lead to convey effect or means long process block shorter ones and stack based algorithms. FCFS scheduling executes the process in order of their arrival times. The program calculates the waiting time and turnaround time. Waiting time is a time a process spends waiting in the queue, and turnaround time is a total time taken by a process from arrival to completion. Here sorting process by their arrival time. Here we are calculating the waiting time by is equals to waiting time I minus 1 plus burst time I minus 1 minus arrival time. Next, we are calculating the turnaround time by using this formula. Turnaround time is equals to waiting time plus burst time. Stack implementation. Stack implementation in a processor. Stacks, pointers, manages function calls in CPU, and role of stacks in interrupt handling. Stacks are used for saving the state of process during interrupts, and the memory management. Your stack memory and heap memory. Stack memory stores local variables, function calls, and is managed automatically, and heap memory used for dynamic allocations of memory.
code. Firstly, we are using the library functions like stereo.h standard library and string. So now we are using function prototypes, that is void calculator, void process scheduling, and void stack operations. Next we are using stack operations and functions. So we are defining the maximum value 100 in stack of maximum. So int top equals to -1. Next we are using the function void push of int value. If top is greater than or equals to max minus 1, so the value is given like this, so it will print stack overflow, else stack pre-increment top equals to value. So if it is not overflow, it will print stack pre-increment top equals to value, then it will print push %d onto the stack comma value. Next, pop function. Here, if top is less than 0, it will print stack underflow, or else it will print popped %d from the stack of top decrement. It will decrement the value. Next, it is going to display. So here, if top is less than 0, it will print stack is empty, or else it will print stack elements are. Here it is using for loop. So first we have to declare the value, and then I less than or equals to top, we have to present the iteration and increment. So next it is going to print %d comma stack of I, print f, next line it will print by n. The main function. So int main, we are using main function int choice, and next do loop. So printf, it will give the menu. So printf 1 dot calculator, first one will be calculator. Next printf 2 dot process scheduling, that is fcfs by n. Next printf 3 stack operations, thirdly it will print stack operation. Next printf 4 exit by n. So printf first it will ask for the choice, then scanf %d comma and choice. Next switch of choice. So case 1 will be the calculator to calculate the results, and next break. Case 2 will be process scheduling. So after that break. Case 3 will be stack operations, break. Case 4, it will exit the program, and it will print goodbye by n. So break. Next default, defaultly it will print invalid choice, please try again by n. Next next we are using the while loop, that the choice should not be equals to the 4. Next it will return the 0 value. Next, we are using the calculator function to calculate the results. So, void calculator function, double num1 comma num2 comma result. It will print the double num1 num2 and the result. If you have to put the num1 num2, and it will give the result for us. Next, the operations are printf by an calculator, that is menu. Printf enter an expression. For example, here we have taken example 3 plus 4. So it will give the result as 7. So switch of operations. Next case plus result equals num1 plus num2 break. So case is minus. So result equals num1 minus num2 break. Next case start, that is multiplication, result equals num. Using process scheduling function. Here the void process scheduling method, int n, integer n we have to use. So printf it will give by n process scheduling, that is FCF menu, and next it will print. We have to give enter the number of process to proceed. So scanf %d comma and n, because we have used int n. So int arrival of n comma, we have to put arrival time, bust time, waiting time, and turnaround time for each process. So next for we have to use for loop. So int I equals to 0 we have to declare, then we have to give the iteration, that is I less than n and I plus plus. Next it will printf process %d comma I plus 1. Next scanf %d, that is arrival time, %d, that is burst time, comma arrival of I and burst of I. Next we have to use FCFS scheduling algorithm. So waiting of 0 equals to 0, that is has to first process has no waiting, so only we have used waiting of 0 equals to 0. Next again we have to use for loop, that is declaration, iteration and increment. So waiting of I equals waiting of I minus 1, burst of I minus 1, arrival of I and arrival of I minus 1. So if waiting of I is less than 0 of waiting of I equals to 0, because we have used this because no negative waiting time is allowed in this, so only we have used like this. Next we have to use for loop. So for int I equals to 0, I less than n, I plus plus, turn around of I equals to waiting of I plus burst of I. Again it will print process arrival burst waiting and turn around time by n. Again it will use for loop and printf. For everything we have %d process arrival burst waiting turnaround time. So for again it will use for loop and it will print arrival of I, burst of I, waiting of I and turnaround of I. Next we are using stack operations. So we have to use choice and value. So printf by n stack operations, the menu, and then do loop, printf n1 push n by 2 pop display and back to menu. These are the cases. So printf, first we have to enter our choice. So enter your choice. Next scanf %d comma and choice. Next we have to switch our choice. So case 1 is printf enter a value to be pushed. So we have to enter a value that need to be pushed into the stack. Next scanf %d comma and value, push of value, break. Next case 2, in case 2 it will pop the element. Case 3 display, break. Case for printf, it will returning to the main menu, then break. Defaultly it will print invalid choice, please try again. Next, while choice not equals to 4. Let us see the output for this code. So enter your choice, we will put 1. So enter an expression. For example, we have taken 3 plus 4. 3 plus and 4, it will give the result is 7. Then enter your choice 2. Let us put 2 for the choice. Then it will ask the enter number of process, we will give 3. We will give the process number 3 and enter 0, 4, 2 and 6 and 3 and 5. We have given like this. So we have they have give process 1 2 3 arrival burst and waiting, we have got this one. Next enter your choice 3. So we have enter a choice. So let us put enter choice 1. So enter the value to push is 10. Enter 1. Again we will push some value, so 20. So we will give the choice as 2. It will pop the 20 from the stack because the case 2 is pop. So 3. So stack elements we have got as 10. Then we will give our choice as 4 and it will exit from the menu. So guys, this is our output.
And the finally conclusion of this project is the project integrates the multiple foundational computer science concepts into a single program, demonstrating their practical applications and interdependence and improved understanding of OS scheduling mechanisms and their relevance. Learn to connect software design with hardware principles for modular and functional system design. Thank you.